All right, let's start. Thank you, everyone. My name is Sylvain. I'm Algolia's VP of Engineering. I'm also lucky enough to be their first employee. If you don't know Algolia, we are doing search as a service. So you might not know the Algolia brand, but if you are searching on e-commerce websites like Birchbox or Lacoste, or if you're using Twitch, if you are searching Hacker News, if you are searching Webpack, React.js website, all those websites are using Algolia under the hood in order to provide their web users and mobile users with search results. It turns out that since the past 6 years, we have been iterating on our REST API in order to provide all those developers with something rock solid in order to provide search on their website and application. It turns out that today, we have been growing our infrastructure from 1 to 2,000 machines, and we'll tell you more about those ones, but they are actually bare metals machines, so physical hardware. We are not really doing cloud. And we are processing right now about 40 billion API calls doing searches every month. 40 billion API calls doing searches, it's about 16,000 searches every second, if we do an average. Of course, search is not something that you can measure average, so we are processing way more than 60,000 searches per second. To give you a little bit more background about how we went from 1 to 2,000 machines and from 1 to 40 billion searches a month, I need to provide you a little bit more context, because back in 2012, our two co-founders didn't build a search API. They didn't build a REST API. It wasn't actually online. What they built at that time was a mobile search engine. So it was a small SDK that they were selling to mobile developers to build a search technology on the mobile phone. So totally offline, something that you would embed in applications like Evernote or whatever would be on your phone at that time in order to search the content that was inside the mobile application. Turns out that back in 2012, I don't know if you remember the kind of phone we had at that time. It was the iPhone 3G. It was this poor Android phone, no CPU, no RAM. They had to build this search engine from scratch and optimize it at the millisecond level. It was running great on the cheapest Android phone, but the business was not that easy. Selling such a mobile SDK was not that easy. So what they did 6 months later is that they pivoted the company to a SaaS company. And the unfair advantage at that time was we had to rebuild this search engine from scratch to run on cheap Android phones. And targeting both Android and iOS, they built this search engine in C++, optimizing it at the millisecond level. We took that technology and we packaged it in an Nginx web server and released our first version of online search as a service API. Same code. Of course, we packaged it with a little bit of authentication, API keys, and all what is required to build an API and a SaaS API provider. And at that time, it was just running on a single machine. We had in mind how to build a highly available API, but it was definitely not implemented. We had an issue back in 2012 or 13, looking for the best hardware to host such a service was tricky. I don't know if you have been even setting a search service, if you have been building your own Elasticsearch cluster, but if you know a little bit about search, you know that search is highly resource consuming. It's super heavy on disk at indexing time, it's super heavy on CPU at search time, and you need a lot of RAM. Back in 2013, having those high-end servers on the cloud, on AWS, on GCP, or whatever cloud provider was at that time, wasn't just something we could afford. Because what we wanted to have is the perfect hardware to be able to provide all those developers and end users with the best and highly performant search API. So we did that crazy choice of going bare metal, and at that time, we were just buying machines hosted in different providers like OVH in France or LeaseWeb in the US. We were running on some kind of machines that are not that common for web servers, because what we were looking for is significant amount of RAM and, most importantly, very high efficient disk and highly cadenced CPUs. I was telling you about highly available because this is the key. We are doing search for customers that are making money with our search results. We cannot be down. And of course, you know that if you're running on a single machine, this is not going to happen, right? It's not a matter of if it will happen, it's when it will happen. Machines are failing, network is failing, everything is failing. If you're running your API on a single machine, it won't work. So we had to build a highly available architecture. And to do that, what we have been designing is that every single Algolia customer wouldn't be anymore hosted on a single machine, but hosted on 3 different machines. And those machines would be doing exactly the same. Every single one of them would do search. Every single one of them would do indexing. And they would communicate together through a master-master replication algorithm. We have been implementing the Raft consensus under the hood. But basically, it was about building clones so that if one machine goes down, at least 2 others are still there. At that time, we also upgraded our machines because if you know a little bit about search, you also realize that if you want to do good performance, you need to have everything into the memory. You cannot afford to go on the disk to answer a query. So from 32 gig, we upgraded our machine to something like 128 gigs of RAM. That was great, but if you are now hosting all your customers on at least 3 machines, you need to balance the load, right? Which machine do you target? So an idea could have been to introduce a load balancer in front of those machines. But at that time, we were not confident maintaining an extra piece of software, and we were not confident about introducing a new SPOF, because at the end of the day, if the load balancer fails, you can have 3 machines, it doesn't help. So what we have done is we have been putting this logic of load balancing at the client level. What it means is that we have been building about 10 API clients, so some kind of libraries that you would use in Ruby, in Python, in Java, in C#, in Go, whatever the language that you are using, that is kind of wrapping the API, and that has the knowledge that every single Algolia customer is hosted on at least 3 machines. They would contact those machines through a host name. So every single time you sign up to Algolia, we give you an application ID, and you can reach every single one of your 3 machines using your application ID -1, -2, -3, .algolia.net. You see there that we were using .io at the beginning, like every single startup did start 4 years, 5 years, 6 years ago. Talent might be one of them. We were so happy to have this IO host name. Very bad idea. For a website with OK traffic, it's probably fine. For an API that needs high performance, worst choice ever. If you know a little bit about how DNS are working, if a web browser or something is contacting a host name, what it will try to do is figure out behind this host name where the IP address is. So it's going to try to reach a DNS server, and it turns out that at the root level, the DNS servers handling the .io TLD are not as fast and as numerous as the .net or the .com. And for instance, if you were in Asia back in 2012, resolving any host name with a .io TLD would probably take between 1 and 2 seconds just to resolve the host name to an IP address. So the first thing we have done is, OK, let's get rid of .io and use only algolia.net. Those smart API clients, because they had the knowledge that every single customer is hosted on 3 machines, they had the ability to fall back. So if you're contacting one of them that was randomly chosen between the 3, and this one doesn't answer fast enough or is failing, what we were just doing is retrying on the other one. What we also figured out at that time is that while a lot of developers think that contacting REST API is something easy and it's just an HTTP call, we also realize how the best practices were not necessarily understood or applied. So you would use those famous REST API client in Python, and you would realize later on that they were not actually checking the SSL certificate. So you thought you were doing a secure communication while you were not. Or the timeouts were not really configured. So you thought that at some point, if the network is broken, it will retry, while the timeout was -1 by default. So infinite timeout, meaning if the server or the network is down, your code will hang forever. So building those smart clients helped us not only to make sure that we were balancing the load at the client level and retrying on the machines at the client level, but was also a way for us to ensure that all the best practices when it comes to security and performance were actually well implemented. At that time, we were 5 developers to maintain 10 API clients in 10 different languages that we didn't really know. That was a lot of pain. But today, I'm super proud that we took the time to build that, because it has been a key differentiator for every single Algolia user, being able to use some API clients that were perfectly fitting what the needs were when it comes to performance. Of course, you probably heard about multi-availability zone. What it means is that if you have 3 machines and if you have those smart API clients, everything will work well until the whole rack where your servers are is down. And trust me, this happens more than often. What happens also a lot is the switch connecting all those servers to the internet get upgraded. If you upgrade a switch in the data center for 30 seconds, it will reboot. So in order to avoid that, what we have been doing back in 2014 was, let's make sure that when we ask for 3 machines, those machines are not in the same rack, not in the same data center. Let's try to find multiple buildings. Maybe it was the same provider, but at least let's try to make sure that the network, the power units are different. So that if we lose one machine, it's not a big deal, we still have the others. That works well until your whole provider goes down. And again, this happens. So maybe not in the region that you are used to host your service on, but we have 16 regions around the world where we have servers. And trust me, in Brazil, in Russia, in Japan, in South Africa, the network and the providers are not as reliable as what you're used to in Europe or in the US. And of course, if your whole provider dies, or if your whole provider gets disconnected from the internet, you might have multiple buildings and multiple availability zones, but at the end of the day, everything is down. So since that day, we are building our cluster of 3 machines using at least 2 different providers. What it means is that every single Algolia customer will be hosted by 2 different providers in their regions. So in France, we are using, or in Europe, we are using both OVH, Etzner in Germany, LeaseWeb in the Netherlands. In the US, we are also using different providers. LeaseWeb, we're also doing co-hosting with other providers. And this works okay. But then you start scaling, and you realize that your customers have their customers everywhere on the planet. So what it means is that if you are Twitch and you want your users to search for the latest live gaming videos, you might have people in the US, in South Korea, in Australia, in India. And by reaching an API that is hosted in a single location, for instance, in Europe or in the US, what you will experience if you are close to the region is a great search experience, meaning the network latency is okay and the search engine is fast enough so you will feel like it's instant. But if you are based in India, if you are based in South Korea or in Australia, just the round trip of the network call to a US-based data center to reach a search API will take you something like 200 milliseconds. This was not something we would want to provide. We wanted to provide everyone with the best search experience, and that means make sure that there is no network latency. So what we have done at that time is making our API globally available. What it means is that our customers still have their 3 main machines in a single region, but then they have the ability to spawn other regions in order to synchronize those regions with the main cluster. We have been rebuilding that from the ground up as well. But ultimately, what happens is that if you are Twitch, you can have 10 machines in the US, 2 in South Korea, 2 in Hong Kong, and 2 in Australia. And then with GeoIP, we can resolve the app ID-123.algolia.net to the closest data center that has the data based on your location. So this is great. This is working very well. And it makes sure that wherever you are on the planet, you have the best search experience because you are targeting a data center that is close to you. At that time, we had 12 regions. Today, we have 16. We have just been adding Middle East, US Central, and a few other regions like that. But again, that was a game changer for us, because if you are providing your customers with an API, think about where they will be when they use it. What we recommend is targeting the Algolia API directly from the end-user browser using JavaScript. And to do that, you need to make sure that the data center is close enough to the end user. Interesting. The image is not well loaded, so that was a world map of whatever. At that time, we were super, super confident. We had multiple providers, multiple data centers. Our machines were all replicated with a master-master algorithm. We had these smart clients making sure that they were retrying if one machine was failing. We were like, OK, nothing can happen. We have finally a highly available API. Until our DNS provider got DDoS. So what it means is that you can have the best architecture ever, but if the guy resolving hostname to IP address is down, you're screwed. Your customers cannot even know where the IP address is, what the IP addresses are, and therefore they cannot even reach your machine. So since that day, what we have done is, OK, there is no other solution. We need to have a DNS redundancy. So today, you can reach out to the Algolia machine through the hostname algolia.net or algolianet.com. So those two DNS are actually exactly the same, done by different providers, so that if one got DDoS, we hope the other one will not. Yes. And this logic is, again, part of our smart API clients. So again, we took the opportunity to patch those API clients to make sure that they have the knowledge that if something is not resolving, let's try with another host name. And of course, you continue, selling your software and your SaaS service to bigger and bigger companies. And at some point, your customers are more and more demanding, and their expectations are higher and higher. and they're asking you about, what is your SLA? Like, how much time are you up? How do you guarantee that you will be up 100% of the time? What we always told our customers is like, there is nothing like 100% uptime. Like, you cannot guarantee that. If there is a nuclear attack in I don't know where, it's gonna fail. But what we can do is provide you with 5.9 SLA. This is the highest SLA that you will find, and what it means is that instead of using only 2 data center providers, we have only in a few regions, US and Europe, the ability to host an Algolia customer on 3 machines that are provided by different providers, different building, different network, different power units. On top of that, 2 DNS. So we are confident that those 3 providers won't go down at the same time. Turns out that there is still a trick behind this, because those servers cannot be that far away from each other. Remember that they are doing master-master replication, so they keep communicating together in order to be on the same page at any time. And of course, the further they are from each other, the more you will also have to deal with the network latency. So it's only available in a few regions because those are the regions where we can have reliable providers of bare metal machines that are not that far from each other. Everything was working fine. And last year, I don't know if you heard about GDPR, but this is where you realize that, okay, your API was working fine, it was highly available, your customers were super happy, and now they start asking about, by the way, what do you do with our logs? What do you do with our data? Where does it go? So our answer was, but you choose the region where you want your Algolia service to be hosted, so everything is there, and we are sending the backups to the US. And we are also processing the logs in Canada. And shit. So at that time, what we have done is, okay, if you want to have a globally distributed API, you also need to make sure that everything that is processing this API or the logs done or outputted by this API is also globally distributed. What it means is that we now have multiple regions that are processing logs of our customers, that are processing the monitoring, that are processing all this data that is related to our customers. And again, this took us a lot of time in order for everyone to be able to say, okay, I'm using Algolia from Germany, and I know that everything is in Germany. But of course, it's not over, and at some point, we had another issue. What happens is that if you remember our API clients, what they do, they retry on different machine if they fail. What it means is that the load balancing that we do at the API client level is just a round robin between the 3 machines, but then you keep targeting a single one of them until you perform that many requests or until the TTL of the hostname resolution is over and so on. So this setup works very well if the number of API clients reaching to your cluster of 3 machines is big, meaning that if you have a lot of clients, the load balancing between 3 machines will do okay. It's asymptotic. In the long term, the amount of requests that every single server will get is okay. Turns out that some of our big customers that we cannot tell the name about want to hide that they are using Algolia because they are public, because they don't want, for a lot of competitive reason, they don't want to know that they don't want their users to know that they are using Algolia. So what they do is that they proxy every single search requests through their server. And it's their servers that are reaching out to our API. It's not anymore the end user. So the end user is reaching their machines, and their machines are reaching Algolia. Depending on how their infrastructure is designed, maybe it will be a small amount of machines reaching our API. So let's take the extreme situation. Let's imagine that you are a big website. You have a lot of traffic, but your architecture is designed so that all the searches from all your users are actually going through a single machine, and this single machine is reaching the Algolia API. Because it's a single machine, it's probably using a single instance of the API client, and therefore the API client will pick one of the 3 machines and start contacting this machine. So ultimately, the load balancing is not anymore balanced, because all the requests will go through a single machine. So earlier last year, when this started to happen, what we have done is that we have built a real load balancer at our level, not anymore at the API client level. And it's kind of lazy load balancing. If you start reaching the load balancer, it will try to understand, based on your application ID, where are your machines, where is your main cluster, where are all the replicates around the world, and try to figure out how to route that. It will obviously increase drastically the performance if you are connecting and performing all the requests through a single machine. It took us 5 years to get there. What I learned is that software is hard, but when it comes to hardware and when it comes to network, it's even harder. We are lucky at Algolia to be maintaining and owning the whole stack from the software level, we built the search engine, to the hardware level. We are actually asking our provider to provide us with a very specific CPU, a very specific RAM, a very specific SSD. And we are also asking our providers to have a very specific network peering and making sure that we maintain and own the whole stack. But it took us 5 years to have this 5.9 SLA. It's something that doesn't happen overnight. We have been sweating a lot. I cannot thank PagerDuty enough for all the times they have been waking up in the night to fix what we have built. But yeah, that's it. 40 billion MBA calls a month.